Hey everyone, welcome to Tutoring. I hope you're having a great day. Today we are doing a topic video on differentiation, so chapter 6. More specifically, we're going to learn the origins of how, the differentiation formula for inverse circular functions came about. So, your y equals sine inverse x, y equals cos inverse, and y equals tan inverse. We're going to learn how the formulas came about. So let's start off with y equals sine inverse of x. If I want to find dy dx, you'd have to differentiate this. We haven't learned how to do that yet so far. So I'll show you the techniques on how this came about. You don't have to know this, but it's good to know the origins behind it so that it's useful. It's a useful technique as well in the exam. So we don't know how to differentiate that. Let's make it something so that it looks familiar to us. So I'm just gonna take the sine inverse, bring it to the other side, and we have x equals sine y. This looks differentiable, right? dx dy definitely can differentiate, and we get cos y, positive cos y. The goal is to find dy dx, so we flip dx dy, and we flip the right hand side over as well, so that is we get 1 over cos of y, and then the problem is over here. Now we want dy dx differentiate in terms of x, but then we have a y in our right hand side. That's not in terms of x, right? So what can we do? Well, guys, what you can do, I'm just going to drop a formula or a rule more specifically here, and that is a sine square y plus a cos square y, that would equals to 1, right? So identity rule. We need to change this y into x. Now, I'll show you how that's possible. Okay, another way of writing cos square y, of course, is I'm just going to manipulate it around, and that is 1 minus sine square y. Okay, now here's the magic, guys. Cos y is equals to square root 1 minus sine square y. I'm going to take the positive only. And then, guys, if you have a look above, now so 1 minus sine square y, sine y is x, so therefore sine square y would be x squared. So another way of writing cos y is this. So therefore dy dx is equals to 1 over square root 1 minus x squared. And that is actually the formula. If I was to differentiate y equals to sine inverse of x, this is what I get. 1 over square root of 1 minus x squared. Okay, guys? dy dx, I differentiate that, that's what I get. If you want to look at cos inverse, it's the same thing. So I'll do it quickly here. X equals to cos y, and we have the x dy, differentiate that, we have negative sine y, and then of course we flip it, so dy dx, we would get negative 1 over sine y, negative 1 over sine y. I'm going to use identity rule again, sine square y plus cos square y equals to 1. Now, this time I want sine y by itself, so sine square y equals to 1 minus cos square y, okay? And therefore, sine y, if I square root the whole thing, it is 1 minus cos square y. And cos dy dx right here is negative 1 over square root of 1 minus cos square y. So another way of writing sine y is this. I'm just going to replace it in. And another way of writing cos square y would be x squared. Okay, so that's how you came about the cos inverse differentiation formula. Negative 1 over square root of 1 minus x squared. Okay, now let's look at the last one, tan. It's very similar as well. It's just a different identity rule. So x equals to tan y. I'm going to differentiate tan y in terms of y, and what you get is sec square of y. Okay, now I'm going to flip that, dy dx, and you'll end up with 1 over sec square y. Okay, it's you can of course write it as cos square, but I want to leave it this way because it is more convenience. Now the goal is we need this in terms of x, but this is y. So we use identity rule, and that identity rule is 1 plus tan square y. So I'm just replacing theta with y, or x with y really, equals to sec square y. Okay, so dy dx, another way of writing that is 1 over 1 plus tan square y. And what is tan square y? That is x is tan y, so x squared is tan square y. So 1 plus tan square y is 1 plus x squared, guys. And dy dx, if you differentiate y equals tan inverse in terms of x, this is what you get, 1 over 1 plus x squared. That is actually the formula, guys. So I just wanted to teach you the topic for, or how the origins of differentiation for these 3 inverse circular functions, and that's over here. Hopefully you found this video useful. You don't have to read the textbook too much, but aside from that, guys, thanks for watching, and I'll see you in the next video.